Okay guys, today we will gonna discuss or today we will implement AODV and DSR routing protocol. AODV is a ad hoc on-demand distant vector routing protocol and DSR is a dynamic source routing protocol. So today we will implement AODV and DSR and we will compare them using performance metrics like average throughput and end-to-end delay. So for this demonstration I'm using that. So let's get started. So first of all we have to open your terminal. So from terminal we are gonna use NS2 which is network scenario generator to create our network. So to test we have to type command java-jar and then the file name 2.1 version. It seems like error. I have forgotten to give the extension, that is .jr. So let's try again. We have to keep the same again, just we have to put .jar. Now you will see network scenario generator will pop up. So from here you have to choose the scenario and you have to click new wireless scenario. So after you click in the new scenario you will get several options like nodes, agent, application, parameter, TCL, extra. So I will come on this by one. First of all we have to make the nodes. So for these nodes I'm using a grid format. So my design will be based on grid format so that it will be easy to me to create the format grid. Let's take 40 nodes. So for this I'm taking 5 into 8. So 5 rows will be 5 and there will be 8 column. And I will select a distance, vertical and horizontal distance as 100. I don't want my nodes to be far from each. So after editing, so I will keep a vertical distance as 100 and then horizontal distance also as 100. So after this you simply need to point your mouse in the user interface and just press a one click. Now your node will be generated. So for this demonstration purpose I have been using 40 nodes. So to get a better view, let me zoom it out, and using the hand option I can control the viewing point. So now I think it's better. You can see here, you can see there are 40 nodes for this demonstration. So next option I will choose agent. From agent I will choose TCP protocol. So I will take two source code, means two source node using TCP protocol. So I'm using node 0 and the other node as my two source, and I will use two destination node. So using TCP sync I will select two destination source. Now I have to sync this as source to destination. As you can see there will be red line, that means the file will be transferred from source to destination. So after doing this I will take application. In application I will use file FTP to transfer my files from source to destination using FTP protocol, file transfer protocol. I will take start and end time for FTP protocol as 1 to 10, and then for the next I will take as 1 to 15. After using this we will go to parameters, and from parameters there will be options like simulation wireless channel. So from simulation I will give this trace file name as I'm using AODV, so I will give AODV and the number of nodes. I'm gonna give AODV 40 and AODV 40 for both the trace files and for the num file. because when you execute this file you will get two additional file, that is trace file and num file. So I'm giving AODV 40 for this, then num file also I will keep it as AODV 40. So next we will go to wireless. From wireless we don't have to change anything, we just have to change the routing protocol. So from that routing protocol I'm gonna choose AODV and leave it as it is. No need to change any other things, save as default. Later on you have to save it as default, so no need to change any other things. So just save it default, then done. So now we have to generate our TCL file. Simply click on TCL, you will get a TCL code. So from this code we have to save now. So after saving this file I will save this and I will create a new folder as demonstration. After making file demonstration I will open that file and then I will save this file as, since my protocol is AODV, I will take AODV 40 then .tcl, the extension should be TCL, then save the file. So after saving the file now we can close this, and similarly like this steps I will create some more nodes and I will take the same process for DSR also. So to execute now we have to go to our file demonstration. So after going demonstration we will open our terminal here. To run this code we have to type ns, we have to type ns and then we have to give aodv.tcl. so we will run this TCL file. After running TCL, so one point to be remembered, that after execution TCL file we will get two more additional file, that is .nam and .tr. The trace file will contain a huge number of data and the num file will contain the graphic information. So after execution TCL file we will get two additional file. So just we need to remember this point. From the trace file we are having the information of packet and all. So now let's run this, if it successfully run the packet or not. Let's see. We have to click on that button play. Let me speed up the time. Now you will see there will be a packet delivered from source to destination. Successfully the packet is transferring from source to destination. So this is successfully run for AODV protocol. So similarly like this we have to do for other protocol as well, for DSR and so on. It will be the same steps. Since I have done with AODV protocol, now I will simply create DSR. So simply you double click on this, open the file and simply create a new file and copy this AODV file, new file, then just copy entire thing of AODV and paste it in your new file and save this file as your protocol name. So I will save this as my DSR. Since it is 40 node, I will take it as DSR 40. There will be a simply changes, just we need to change that, and the rest it will be remain same. Make sure that to compare any node, any protocol, the structure of node should be the same and the designing part should be the same. So now we simply replace this AODV with existing protocol, that is DSR. So wherever the DSR file is we have to replace it. Since this is our trace file name, so we have to remove this and we have to give as DSR trace file. So when it will execute it will give us DSR 40 trace file. Simply we need to change from here. Then let's see, is there any more AODV file, so we just have to replace that AODV in DSR. So here we can say one more is there, so here also we will remove the DSR AODV and keep it as DSR. So this process is same, and using this you can just change the protocol and the number of node will be same. And okay, so let's run this again. I will open the terminal tool here. So same command we have to give ns. This time our protocol is DSR 40.tcl. so let's check whether it is. Oh, we are getting some error. Let's fix this. Let's fix this error. Why it is error is coming? For that we have to open our file again. Let's open our file to fix this. Let's open, and here we have to give some code, because DSR doesn't support a queue drop tail, so we have to change this file queue drop tail. So the command I will paste it here now. So this is the command. Here the variables are rp is the variable for DSR protocol. So if the variable is equal to DSR, then it will execute cmu pry q. So it will replace the q drop tail q to cmu pry q. The value should be same ifq, and we will replace that protocol with this, or else it will remain as default. So let's save this and run it again. Now it is successfully running. Now let's see if there is a packet delivery or not in this protocol. Yes, the packet delivery is successful in that case also. So this is how you create and design for AODV and DSV. After this, now we have to extract our useful information which are stored in our trace file. So to take a useful information from our trace file, we need a AWK scripts for it to link and to extract the useful information from AODV and DSR. So let's get to that AWK scripts. So how we will link, I will show in this next command. So I have the AWK scripts for end-to-end and general output. So let's run this end-to-end and extract the details from this DSR or DSR trace file or AODV trace file, same in the both case. So let's extract this end-to-end delay and perform the calculation. So for this, let's open again the terminal. Then for this command will be gawk -f, since we are opening the file, and the scripts which we want to run. In this case we want to find our end-to-end delay, then it will be end-to-end delay.awk file, and then which protocol we are going to use. For here I am using AODV 40 node and .trace file tr. Hit enter. Now you will get the information which generate packet, receive packet, packet delivery ratio, and the last are important is end-to-end delay. It showing end-to-end delay. Now we will do the same things for our second performance matrix is average throughput. So we'll just simply change the file name, as I have already written the AW script for the average throughput. We just simply give the file name and we will hit enter. and we will get our desired values from the trace file. Here you can see this is our average input, the number of packet sent and received successfully from source to destination. So in the case of DSR, it will be the same process. Just simply give the DSR trace file as a file name DSR, in my case dsr40.tr. so I will get the DSR average throughput. Again I get the DSR protocol throughput. Same in the case of end-to-end delay for DSR, just simply change the DSR instead of AODV, just simply change dsr40.tr, then hit enter. So with this we can get our desired value. So the process will be the same for to getting the value. So next I will create a node of 20 and 80 similar file for both the protocol AODV and DSR. Then I will come to my next process, what we have to do. So I have successfully created the file for nodes 20 and 80 for both the protocol AODV and for DSR. I have created separate and same file, and then we have the same it will be same script end-to-end and average throughput. So as you can see, these are my files for 20, 80, 40. The process will be the same to create the files, just you have to decrease and increase your number of nodes, but main thing, your designing part should be the same and the parameters which you use, it should be the same. So now to generate our graph, we need data to store in a file. So for that we will open our terminal. So just for this demonstration I will open one value from end-to-end script for DSR. So to store this value we need another file, so that we can later on we can plot the graph. So for this I will store it in a file. I will take a gedit, and since this is end-to-end I will give a file name end-to-end, then the extension will be .dat. It will store the data. I will just simply copy from there and I will paste it here. The data. So I'll paste it here, the data, after copying the file from the terminal. This is for end-to-end delay, this file to store the data of end-to-end delay. So this the number of node I'm taking 20, and this will be for 40, and the last I'm taking 80. These are the number of nodes. So now I will just go to the terminal and copy the values end-to-end delay for DSR protocol. I'll just copy and I will paste it in 40 nodes. So same process you have to repeat for the end-to-end dat and for average data using the same process. So I get my average data is this 2040 is the number of nodes for average. Let me open the end-to-end also. This is my end-to-end data. So this is my end-to-end data. Overall the steps will be the same. 20 is my number of node, 2040 it is my number of nodes, and this is first column is for AODV and this is for DSR. Simply for average I'm taking 20, 40, 30, 80. This is first, this one is for AODV, and this is for DSR. So next we will plot a graph. To do that, we have to open the terminal again. Now we will use Gnuplot. If it is not installed in your system, please install it using sudo command to install this Gnuplot. So I will just write Gnuplot and hit enter. So here I will write a code to generate my graph. So I will take first a set x label, that will be my x-axis, and I will label my x-axis as a number of nodes. Then I will hit enter. The next I will set for y for y-axis, y label I will take. Then I will in y, since I'm gonna take for my end-to-end, I will mention it end-to-end delay, and same the thing you can do for average also, it will be the same process. So I just simply write end-to-end delay for this. Now I will enter. Now I will plot the graph using command plot. Then the file which I have created previously, I have to mention it here in a double quotation, that is end-to-end.dat. I give that file name as where my all the readings are there, and it will help me to create a graph. So end-to-end.dat using 1:2, it represent the column 1 and it select the column 2. 1:2, it select the column 1 and column 2 with line spot. So since it is my AODV column, I will give title as AODV in the double quotation. So we have to give a comma, then again the same line, the data part, end-to-end.dat, again the same, using 1:3, 1 represent the number of nodes, first column, and 3 which is DSR value. I will give a DSR 1:3 to select the DSR column. So I will give title as DSR. Then we have to hit the enter. So I'm done with enter, and the graph will pop up now. As you can see, in axis there is number of nodes, in y-axis there is end-to-end delay ratio. Now since by this graph we can say that AODV performs better and DSR is much more high as compared to AODV. So to save this file, we have to simply click this file, that up button, and we will give this file name as end-to-end graph, and we will save this file, end-to-end graph, and I will save this file. This is the format, and then I will save the file. So using this, now I will quit the command from here. Quit the command. By using simply this, you can plot the graph for average. For average will be the same, just you have to change that average, that you take the data of average and plot the graph same as I have shown for end-to-end. So now I'll close the terminal. So now this is the graph for my average. This is my graph for average, and the next graph is for my end-to-end delay. So this is all my about research. Thank you. Hope you like it.